Wow, this is going to be cool. I got 3 monitors to watch.
I like it. I like it a lot.
Yeah, because I've got nothing else going on here. I've muted. Oh, really? Because I'm not touching my keyboard. I move my mouse. Okay.
Yeah, they just kick up.
I can get some tape and block the fans off with that.
Hello, everybody. I'm hoping you can hear me on the live stream. If you can, could you give a thumbs up in the Teams chat? Yeah. Yep.
You'll see starting soon.
I just switched back and forth from starting soon. Hello, everybody. Okay, we got thumbs up. We got switch your video, David. Hello. We're going to get started here. Glad everyone can hear us. And I will do the introduction. So, hi, I'm Greg Theron, and I am one of the presenters today. And I'm going to hand this over to David.
Hi, everybody. I'm David. I know probably all of you, which is awesome. Thanks for signing up and coming today. We hope you get a lot out of it. As you know, Greg and I are part of the 3D Make It experience on YouTube. Then we produce a lot of content similar to this for our YouTube channel. So it's great to get to share with you guys and learn together. Yeah. So throw it off to Fish now.
And really big, 1 second. Well, it's not difficult, it's just awkward. There we go. Woo. Almost. Fish, did you unmute your mic? Or do I need to do that? I think I did it to him, so I wonder if I had to undo it to him. I can't unmute you. You have to unmute yourself on the Skype. You just click. There we go. How about now?
Okay, I'm still
You should be good now, Fish.
okay, am I coming through to everybody? All right, Aaron can hear me now. Zach can hear. Good. Okay, now we're good to go. Sorry about that. So yeah, I'm going to take you through 3D Builder and just going through the basics of 3D Builder. I consider 3D Builder kind of the notepad of the designs. It's really quite simple. I've been playing with it for a little bit. I really believe in keeping things simple. So I'm going to take you through just the basics of how to build just a basic name tag, and then we'll show a few other features. So I've got my screen displayed here. So I'm going to start with inserting. You can pretty much build your nameplate on any of these designs that you'd like. I'm going to do a wedge. So when you do your design, when you choose your design, a little menu down here at the bottom will come up. And here you've got your move, your rotate, and your scaling. So for now, I'm going to just click on my scaling, and I'm just going to increase the size of it a little bit. So you'll see that I've got the arrows, and I can just pull on the arrows, the double arrows.
GT, the video seems small on YouTube. Keep going, Fish.
So there's my basic design. You can click anywhere on the screen and rotate. And then if your screen is not centered, if you double click anywhere on the screen here and the bottom here, it will reset. And then I'm going to move my design over here on the build plate. I've discovered with 3D Builder that you have to be north of the numbers and east of the numbers. If you put it here, when you try to import it into Cura, it will be off your build plate. So I've gotten into the habit of starting all of my prints pretty much just right here where I need them. I'm just going to scale a little bit more here. So there's the basic shape for my name tag. Then I'm going to go over here to my edit screen, and I'm going to click on Emboss. Emboss will give me my numbers, my lettering. I've got some other shapes and stuff in here. Here I can put my, I can put it on cylinders, I can put it on spheres, or I can put it on the flat. So I'm just going to put it on the flat for now, and then I'll show you kind of here in a few minutes how to do it into a sphere. So basically that is the beginnings of my nameplate. I can change my font styles. So we can go with the standard Times New Roman. I can increase and scale the size of it. To bring it to higher or lower, I can move it up or down. And then if I want to, I can add a shape to it. Oh, sorry. Control Z is your friend. I forgot to click the check mark Emboss. So now my model is embossed, and you notice that I have a different color here. With the emboss, you can actually change your colors of each object. I find it really easy for me to work in 2 different colors. So I'm going to add a cute little star to mine. And then I can move my star pretty much anywhere I need it. And then I can emboss that as well. So now I've got my star and I've got my basic nameplate. Then once I get my basic nameplate done, I want to Control A and make sure that I've got everything around selected, and then I can merge. And what merging does is that takes each of the pieces that you've put in and it makes it one unit. So now if I grab it and move it around my screen, it all comes at the same time. One thing that I have found that sometimes you get a little aggressive and start moving things a little much. We can always go to our object menu, click settle, and it will bring it right down to the build plate again. So that in a nutshell is my basic shape for my name tag. So I am going to try a sphere now, and I'm going to build a nameplate on the sphere. So I'll make sure that I'm in my move area, and I'm going to move this. I'll put it into the, I'll move this off to the side. When you're working with more than one object on the screen, it has a tendency to want to choose the whole thing and move it all as one unit. If you just double click on the object that you want, it will just move it as one unit. So I'm going to scale the size of my sphere, and then I'm going to go back to my edit, or to my edit and my emboss, and then I'm going to use the spherical setting, go back over here to set up my text, and it will wrap my text right around the object. And the same goes for cylinders. The same goes for for spheres and cylinders. I can increase the size of it. I can move it around. I can put it a little bit deeper into the object. I can pull it out more. So if you want to put some kind of texture on it, you can certainly do that. And then, of course, I'm going to click the emboss. And now I've got my sphere, so I can actually have my nameplate, my name tag on my sphere. And then I'm going to merge it. And now it's all one piece. You can also remove sections if you'd like. So for instance, I'm going to come back here to my this one. Bring it back over. So you can also remove stuff. Sometimes it's not as easy in this one.
Fish, you want to go back to show the merge for a second?
Oh, yes. Okay, Control Z is your friend. Control Z is a shortcut for undo. So what I can do, I'll show you the merge on two objects. So you'll see that I've got my objects. I've made them so that they're kind of sticking into each other. And now you'll see that I am moving them as a separate object. Once I highlight them using Control A, I can merge. And now it becomes one object. Unfortunately, this program does not come with an unmerge function. It allows you to merge them, but doesn't allow you to unmerge. So what I've been doing when I've been playing around with different ones is I save quite often, and I'll save my different So I'll save each object as nameplate, pyramid, nameplate, sphere, and then I've got each individual file in case I need to go back. So what I'm going to do now is I'm going to show you the subtract function. This took me a while because I was looking for a delete function, but it doesn't have. It's the subtract function. So I'm going to insert another wedge. For beginners, I like this program because it's it's quite user-friendly when you get into using it. So now what I'm going to do is I am going to expand it. When you do click on your X, Y, and Z axis, you can manually choose your numbers. So I'm just going to move it just a hair more, and then I am going to hit my subtract, and now my object is relatively hollow. I don't like the way that looks, so I'm going to Control Z, and I will go back in, select my object. I'm going to just want to increase a little bit down here because I want to take a little bit more out. I want to go a little bit more in, and then when I subtract, looks a lot neater now. I discovered the subtract when I was making an object. I'm just going to discard my scene. I'm going to open up and I'll show you where the subtract comes in very handy. So I made this design here a while ago. It's a cover for an Arduino. I found online an Arduino bracket that my Arduino slides into, and I wanted to cover it to keep it from dust. So I designed this cover, and I used a lot of subtractions in order to hollow the object out and to make the grooves so I can actually slide. I've got another slide that goes in here that attaches a small fan to it that blows the air through and keeps everything nice and cool. Another feature that I like in here is the rotate feature, the pitch, yaw, and roll, just like an airplane. So if I want to change my pitch, I'm going to go 180 degrees. I'll accept that, and it'll flip over. When I print it, I make sure that I do print it upside down like this. Then the only supports that I've needed in here is a little bit right in this small space and a little bit of support in here. And of course, right on the edges, on both edges, I've needed a little bit of support as well, but those supports just peel right off.
Okay, looking good, Fish.
So yeah, and if you want everything more precise, these are your friends. I do have a set of calipers at home that I do measure within the millimeter and the tenths of millimeters. So entering these coordinates manually sometimes will get you a lot more of an accurate. If you need to double check how something is looking, there is a ruler. So you can actually measure across and find out that, okay, I'm 72.47 millimeters across. So there are some different tools, and I recommend just going in and playing with things a little bit. It's a really, really nice basic program. And then as we go along today, it will get a little bit more advanced. And
Okay.
that's pretty much.
Maybe show them the export, Fish.
Yes. So I'm going to save. I'm going to save as. Make sure that I can go STL, I can do an OBJ format. So either STL, OBJ, or the 3MF will open up in Cura.
All right, cool. All right.
And that is 3D Builder Basic in a nutshell.
Okay.
You can.
I will just switch down to my screen, and Fish, no offense, but the background noise, I'm just going to mute you again.
Okay.
Fish, we love you.
Okay, so that was 3D Builder. Hope that was helpful to anyone who hadn't seen it. It's available to all schools for free. It's part in the Windows Store. So if anyone wants that, yeah, you can do that. So I'm just gonna. A lot of you have seen Tinkercad, but for those of you who haven't, I'm just going to do a quick overview of Tinkercad. It's very easy to use. It's easy to set up classes. I put out a doc in the Teams files. If you go in there, and it's also in the class material. That has a little guide of how to set up classes and whatnot. I actually made student logins for all of you if you really want to log in and whatnot. There's a link there, and you can follow along, or you can just watch my demo. Just like 3D Builder, it uses primitive objects to make all of your models and whatnot that you're doing. And then you can export them to STLs. So let me just switch out of this 1 second and go over to Tinkercad. All right. So I'm going to make a name tag. And I'm going to just sign in. Sorry, it signed me out because I waited too long. And get rid of my daughter. I'm signing in as the class teacher. Yeah. All right. So I'm going to create a new design. And one thing about Tinkercad, if you look at the top right over here, or the top left, it randomly gives you a wonderful name. So feel free, if you don't like the name of your project, you can change it to something less exciting. And so I'm just going to use it. It's really easy. You've got your work plane, and then you've got your objects on the right hand side here. you can drag, we've got hollow objects and we have solid objects. The hollow objects are for adding holes into whatever you're doing. You can also switch your object that you have and make it a hole if you want. So I'm just going to drag a square primitive over here. Now I can drag this any size I want, but I can also click the numbers and say I want it to be 100 long. Oh no, that's too long, so I actually only want it 30. But I would like it to be 100 long that way, and then I want to shrink it down a bit because it's a little bit too high, but I'll make it go 5. So now I've got a nice rectangle there. On the right hand side here, you're also able to change all your different steps. If you wanted to, you can make it change the number of triangles. I think in it is that one, and then you can change your length here. So you don't. There's lots of places to adjust your size. We'll go 20. There you go. Now you can take another object. So I'm going to just take text, drag it on here. I'm going to change the color so it's easier to see. And you can then, on the right here, just put your name, do whatever you want. Why isn't it there? There. And then if you want to increase the height of your text, you can change it here, your level. Oh, why am I didn't want that tool. Why did I get that tool? But you can change your height of your text. You can move it deeper into your object. If you want, you can use the text or any other object to cut. So I can click the hole tool here and remove material from my object. I kind of like having a higher bit of text. I can also then, if I'm going to make a key tag out of it, I want to take a cylinder and I can reshape the cylinder, make it an oval. Then I can put the oval inside my object. Now I have a hole in my object, so if I pan around you can kind of see that. Now I can also then take this all and I can group it. Up top here allows you to group your objects together. So that way if you're making more than one thing, it's a little easier to move it around and whatnot without falling apart on you. You can ungroup it if you need to. And then you also have the option to, once you're done your design, click export and you can do STL or any of the other objects. Now, the other thing I'm going to build is I'm going to just quickly build a vase. So I'm going to take a cone. I'll use that as the bottom of my vase. So you got, then I'll take a sphere and I'll stack that one. So I have a slightly different shape. And then maybe I'll do another cone on here. I can flip it around. Very easy to use. Doesn't want to be straight, but that's okay. It's going to be a very Art Deco kind of thing. Oh, couldn't see my cone to move it up. There we are. So it's not super square, but there you go. We have weird shaped vase that we could print off. Now, what I can do now is then take this object, create an STL, just like before. If I wanted to subtract some stuff or I can increase the steps. So if you find your object is a little too blocky, you can increase your steps, and it increases the amount of triangles and whatnot in your object when you export it to an STL, and it'll smooth the surface a bit. You can't get perfectly smooth objects especially when you enlarge them quite a ways in Tinkercad. You'd have to go to Fusion 360. And so what we can do is we can actually send it to Fusion 360 and say open in Fusion. But oops, include everything. There we are. Hopefully it didn't just do the sphere. And open. Yeah. And application could fail to start. Why did it fail to start? Let's try it again. Well, it worked yesterday. Our live demo apparently is failing. Let me try this again. Send to Fusion. Include everything. Open. Of course, the live demo is going to fail. That's true. Okay. Unfortunately, that didn't work. But what's supposed to happen is it's supposed to bring it all into Fusion here, and then you'll get to see objects. So I'm going to hand it over to David in a second here. I'll just bring up your slide, and then okay, well then I'll just switch to you.
Yeah. Hi everybody, it's me, David. I love the fact that we're calling each other out on emojis. It's amazing. So we've saved Fusion to last, and I know that we have gone through Builder and Tinkercad at probably a quicker rate than we had to. But remember that the Tinkercad and Builder do have some other resources. So when you first log into your Tinkercad account, there is a Learn button, and that one will show you basically what we've gone through very quickly today: drag, drop, how to merge items and make them. So we have those links available to those resources in the
Classroom
classroom links document, right? So now I know which emojis not to post in my class. It's so true, so true. So Fusion 360, and I know probably I did ask the question, and John, if you're up on the stream there too, I know you're in the YouTube chat, but I don't think very many people were using Fusion, so this is going to be a new experience. Now, your school, as an entire district, can make accounts, basically. So you register yourself as a school district, and from there the accounts can be auto-logged in when you use your district email. Now, you might not be attached to a school. In our case, we've registered the whole division, but sometimes people are using individual school accounts that they've created. But I'm going to show you in a second exactly what Fusion has to offer for education, and not just Fusion, Autodesk as a product. So it's pretty amazing. I got a quick few things to flip through, and then I'll show you the accounts and some of the software, and then we'll jump into Fusion. Yay. So far, I don't think I've lost anybody. So we're just going to go into the slide deck here. Um, so Fusion has an awesome function called Fusion Teams. So similar to the way you can make classrooms in Tinkercad, which I'm sure all of our Tinker users use right now in classrooms. So Fusion Teams allows you to delegate control more granular. So if you had a group of 3 students that you only wanted to access a model working on, or a teacher group that was building something, definitely you can have that control over it. It also gives you a unified experience across your Fusion account. And we're going to talk about some of that stuff in a second. But basically, yeah, I've added a little image here. But once I'll show that off in a second. But once you log into your Fusion account on the website, it will convert it into a Teams account. You don't lose your personal account, so you still have access to make projects on your own. But it's a more powerful way to use Fusion. The other thing to note about Fusion is it's all cloud driven. So at no point in general do you have a local copy of a CAD file saved to your computer. So just keep that in mind. It does require an internet connection. And I don't, specifically for Lethbridge School District, I can say that we're not peer to them, so it's going to use our regular internet traffic. So we shouldn't have a lot of problems using it on site, but just keep in mind that if you have a whole class boot up and use Fusion, so if 30 kids boot up in a room and use Fusion, it may take about 5 minutes to actually propagate to the files and stuff. So, but there's basically 3 parts in Fusion. I'll talk about it once we open it a little bit, but basically you have your teams in the top corner here of Fusion. Then you have your projects and your new project folders that you can create on the left hand side. So this is really where you're going to start controlling who can access what inside of Fusion without the web console. And then there's the design workspace, and we'll talk about that because Fusion is full of it. I'm just going to throw the question out here too to everybody. Is there anybody using CNC routers or CNC machining, laser etching, anything like that in the stream? Yeah, Andy, for sure. We're never taking this off of YouTube, so this is your resource forever. So, like, if you want to go vacuum right now or something, you can, and you can watch it after too. But there is going to be a bit of homework at the end because we're all meeting again, I think is next Tuesday. So we'll share that project with y'all, and we'll see where we go from there.
And
so that's just a really quick
questions that come up for next week, please feel free to bring them to next week's thing, and we'll try to, because you'll have time to actually play with Fusion. So.
Yeah, for sure. And I mean, we are a resource for you as well. I know, if you're outside of the district, probably the best way to reach us. So if you aren't part of Lethbridge School Division, not a worry. Just shoot us a message on our YouTube channel, and we will be happy to answer questions. So I'm just gonna dive right in, and yeah, let's do this. So the first thing we're going to do is go to Fusion 360 in our web browser. And I think all of us have downloaded it. Can I get a frowny face if you have not got Fusion downloaded yet? I just want to make sure we're all on the same page here. So if you don't have Fusion, frowny face. But if you do have Fusion, pick the most inappropriate emoji you can find in the list and throw it up in chat. Okay, so we'll wait for that to propagate. But you can see here, once we're in Fusion, on the Fusion specific Autodesk site, we have Managed Products, Fusion Team, and we also have, ooh, there you guys go, getting creative, nice. And then we also have Sign In. So if I sign in to my account, and I'm just doing this to show you exactly how robust our Autodesk environment is. So you guys will see most of the same stuff. There might be some admin-y pieces that you don't get access to because I think Greg Theron and I, we set it up. So love it, John. um, so if I now click here, since I'm signed in on that same little area, we can go to manage products and downloads. And that's, I'm just going to show this off very quickly, and then we're going to jump into the actual Fusion of the day. So if you have it installed, now's a good time to get it booted up, so you don't have to sit at the wait screen. So if I'm just gonna click on all products and services. So once you're in your Autodesk account, this is what you get access to, which is pretty amazing. Once it loads, of course. So Fusion 360 is a unified CAD software, but there are also many other CAD softwares out there. So you can see here that we do have licenses for students. The AutoCAD app is available. So if you have an iPad Pro with the stylus, you can actually leverage that quite easily in here. The ones that I really want to show off, though, we have Eagle CAD. So Eagle cuts circuit boards, so we could actually make our own circuit boards in school, which is really cool. Tinkercad actually just added that circuit block feature, so you can build circuits in Tinkercad and export them now. The other thing is we have a few different Fusion 360s here, and the cool part is Fusion 360, and I'll show this in a second. I know I'm talking a lot. We're almost there. Fusion 360 offers generative design, manufacturing simulations, and other structural other things, which is amazing. Fusion is a $600 program. We get it for free. Absolutely it is. It's also free to private users if you're under $100,000 a year when you're using it. So if you're just using it at home, you're way under that. You're not making money. So if you're using it for a business, as long as you don't peak that threshold, Fusion is free to the general population too. So that's a really cool feature of Fusion. But usually these credits here are, well, very, very expensive, and we actually get them for free. So we just have to log into our account, access them, and it locks it into your account. And when you open Fusion, you get access to all of that. The one other one I'll show you here, specifically for us 3D designers, is Mudbox. So Mudbox, we can apply for more seats. Not a lot of people have actually used it in the district yet. But if you want to do character design, so you're 3D designing Godzilla, you can do it in Fusion, yes. But Mudbox is more of the tool for that. So just keep in mind, we do have all of these awesome applications available. We're not talking about it today per se, but 3D scanning is something that's a very big topic, and some phones have 3D scanners on them, but we can also leverage this Recap Pro app, and all you have to do is take pictures with your cell phone, and then you can start using this Recap Pro and stitching them together into a 3D model. So I don't know if anybody here has ever tried to 3D model from their phone before, but this is probably one of the best ways to get like a replication of your cat lying on your couch or something in that range. Okay, so in a nutshell, that's our Fusion. You can access Fusion Teams from your console as well. We showed that at the front page, so we're gonna jump in here to Fusion. So I kind of want to do the Tinkercad plug or transfer, so I'm gonna sign into my Tinkercad account here and see if it works, because it's pretty powerful, because I know some of us are in Tinkercad, so I'm just gonna show that
work
too.
Yesterday.
Yeah,
we're
we had it
actually
working.
amazed.
So we even tried to game the system a little, because I'm going to talk about something that I'm sure we all want to do. So I'm just going to sign in, and I've got the worst vase in the world made on my work account right now, which is fine. So that's the model we'll be using. So just so you know, Tinkercad uses your AutoCAD account, and Fusion uses your AutoCAD account. So you only need to create one account for both, because Tinkercad is owned by AutoCAD.
Autodesk.
Autodesk, yes, sorry. tinker this. So I'm just going to load that design up and see if we can't fire it into Fusion. So this feature is really cool when it works. Maybe you have to have Fusion open, because when I did it yesterday, I had it open. So I'm just going to go send to Autodesk, and then I'm going to open in Fusion and see what it does. It's thinking about it. Open NL launcher. Yep. So let's see if it kicks in. Yay! So
It worked.
I know, overly excited about that. So it could just be a permission thing when your browser. You got to make sure when you use that export in Tinkercad. But you can see my Tinker design is, well, my Tinkercad skills are definitely not there anymore because I use Fusion 360 now. But so I have this little pot kind of vase thing, and when I exported it to Fusion, it actually brought my pot vase thing in with all the bodies and styles in there. So that's sweet. So that's how the export should work. So for now, let's just go here. We're going to go to Untitled. So when you first come into Fusion, if you do have a Fusion team created, you can switch between the Fusion team and your single user account up here. So you can see I belong to 3D Make It. I belong to Team Monster Destroyer. And then I also have a David Harmon. So that would be my single user account. So you can invite anybody that has an Autodesk account to your Fusion 360 team. So that's pretty powerful. So when you get into Fusion, these windows won't be open. So I'm just going to close it. I won't save that. And then the Untitled one, it'll always pop up with an Untitled one. But if you want to keep things organized, so today we're working on an advanced demo. So we're going to click New Project here. And we're going to call this Advanced Demo, which is semi-advanced, but not. And what we'll do is we'll let that create. I'll go in there. And now Advanced Demo is in my 3D Make It team. You can see here there's like a sharing widget, so you can open it on the web, view it in their online browser. Now, in here, inside of your projects, you can make folders if you want to get even more granular. I'm just going to leave it at the project part of the game here. So you can see here we can invite other users and we can change their permissions inside of this box. So if you had a class, you can just dump their email addresses in and away you go. So now that we have our project open, this is where we really start talking about design. So we made it. I'm sorry it took 15 minutes to get here. So far, so good. Anybody have any questions? That's just accounts, software, that kind of stuff. I'm going to go with no. I don't see any popping up. Is everybody sleeping? All right. So in Fusion, the first thing you want to do is make sure your workspace is set up. So what I always do is I come into my username up here, and then I go Preferences. So once you're in Preferences, since we're using Fusion 360 for 3D printing, there's really one setting we want to make sure that's set, and that is this default model orientation. You can't miss it because it's the only big gray drop box in the middle of the first menu. So that's just on the general screen. You want to change the default model orientation to Z up. And what that does is, since we're building on our 3D printers and laying down plastic, it will make sure that when we model, our model is already orientated in a way in which it makes sense to the printer. So Z up, that's a good one to have. Other than that, we're okay. So I'll just click OK, and we can go out of here. So we're greeted with this screen. So the first step would be to make a new sketch. Now, Fusion 360 does offer other design platforms inside of itself. So if you've ever used AutoCAD or a milling program, Fusion 360 can take the place of that. It has CAM built right into it. So you can use this drop down here to pop out of the design environment and go down to manufacturing. If you were building a printed part that you needed to load check to see how strong it would actually end up, you can use simulation to do that. So today, though, we're just going to hang out in the design. This is where 90% of our work will happen. So we'll just hang out there. So there's some buttons along the top. We can see here that like I have a solid up here, and then it says surface, sheet metal, and tools. When we're doing design, for the most part, we'll stay on the solid tab, but it's important to note that if you need to stitch things together, make crazy sweeps out of nothing, and I'll explain what sweeps and those are in a minute here, we do have different options inside of the top menus, but solid is what we're after. We want to build solid objects so that we can 3D print them. So the first thing that we have to do is realize we're not designing in primitives anymore. And so like Builder and like Tinkercad, we don't have the option, well, we do, but we usually don't use the option to drop primitive objects. But if you did want to, this button here, this create form, will change your menu. So I'll just go back, and that's create form. So if you look about 1, 2, 3, 4, 5, 6 icons in from the left, that's create form. You can actually drop in shapes still. So you can create cubes, cylinders, balls, faces. So it is powerful, and there's a lot of cool things we can do, but we're going to stick to the designing of a sketch and usually how we will run in Fusion. So Fusion, when we first load in, it's just a white background in general. Sometimes it depends on your environment and what version they happen to throw you on, because you could be on a sub-release. You might see a grid here, but regardless, I'm just going to hit create new sketch. Now there's many ways to create a new sketch, and there's many hotkeys in Fusion, but we're just going to go with clicking for now. So if we create a new sketch, you'll see you're greeted with this new sketch construction plane. And so basically here, it wants us to pick an axis that we want to build upon. So when we design in Fusion, usually we're going to be designing bottom up. So we're going to extrude, press and pull, and get our diagrams ready. There are some cases, however, and I will show you an example after, of where we might not use that bottom up, and we might want to go on the side. But for now, we're going to go bottom up. So in Fusion, if you're open, you should be able to hover over the very bottom construction plane, and that should put that grid path even with your screen. So it should kind of be like flat across, and we just click it. So once you click it, we've selected our construction plane. Now, on the side here is the orbit tool. It's very similar to Builder and Tinkercad. They both have orbit tools. You can enter and leave certain display views if you want by right-clicking, and you could go to orthographic view or perspective view. Now the difference between the two is actually your perspective of the object. So if you want to see actual values, you can pop into orthographic, wow, tongue twister, and then that will change how you see it. I'll show you once we get something built. It'll make a lot more sense. So the first thing we're going to do once we click our build plate there is we're going to click top. So I'm looking straight down at my sketch. It makes it easier for us to actually design. So we're going to start with the name tag example that we did, and it will be ridiculously quick, and you will see why. So we're going to click on the rectangle, and that's the second tool in. Now there's other types of rectangles. So if you actually click underneath in the create box, you can see there's lines, rectangles, circles, arcs. These are all things we can draw, which is awesome. So if I hover over rectangle, we're going to look at, we have a 2-point rectangle, and the 2-point rectangle is actually the default option, and that's the one that will give us, so if I put a point down, I just click, and then I click again. It gives us two sides, creates a rectangle. Not hard. The other kind of rectangle that we have, there's a center point rectangle. So this one is really good if we want to get from the middle and we know the dimensions of our rectangle and we want to draw it right in the center of something. We can click in the middle and you can see how it scales the rectangle for us off of one point, and then once we click, it is in there. Now this little thing is new to an update in Fusion. You can actually rotate your sketch and move the point, but we're not going to worry about him right now. We're just going to continue on with our rectangles. The last one is a 3-point, which works very, very similar to a 2-point rectangle, but that one actually uses 3 points to generate. So very quickly, I will just show that one off. So if I draw a line there, and you can see here I put 2 points, so I get my I get length, and then my width would be the third point. All of this is just clicking. So I'm just going to Control Z. It works in everything to get rid of all those. We're going to start with a center rectangle, or a 2-point rectangle, which is the default. So a good size for a name tag, let's say, I don't even know, 7 or 8 centimeters. So I don't know 100% right now what I want for size, so I'm just going to drop that down. And we can see here it made my rectangle, but we wanted to make my rectangle 7, let's say 7 centimeters by 4 centimeters, just for sake of argument. I can actually grab and click on the line, hit D on the keyboard. So I'm pressing D, and you can see here it brings up this little line, and it actually lets me type in the value. So 7 centimeters is 70 millimeters, which is the default for the Fusion environment. But bonus, if in that box you choose, you can type other units. So I could put 7 inches in here, and it will scale it to 7 inches. I can also do math inside of that box. So if I knew that I wanted 70, half of 7, I could go 70 millimeters, which is 7 centimeters divided by 2, and it pops in that math for you. So it's fairly powerful. You can also do that when you're making your rectangle. So I'm just going to plop another 2-point rectangle. Oh, the shortcut to bring up that option is called it's called dimensions, and it's D. It's just the D key. So you're using this one. Very easy. You just push D. While you're making your 2-point rectangle, you can also make your rectangle, and you can see on the sides. Now I can't move my mouse cursor because it'll move with me, but you can see on the top, in the middle, and on the left side in the middle, there's some number entries. They're highlighted in blue there. And all I have to do now, if I wanted to make my name tag, say 3.5 centimeters wide, I would go 35. And I type 35 into that box, and it locks it to 35. There's a little lock that shows up. And then I can also go up top here, and then I wanted it 70 wide, so I will type 70. And then I hit enter, and it will give me my rectangle in those dimensions that I asked for. This one's not quite right, so if I double click in again, I can go 70 on my other example, and then I can change the outside dimension here. So again, that's the D key. It will pop out a dimension, and then it'll go 35. So right now, we're gonna stop for a second. I have 2 awesome rectangles here. Now, who has questions? Who have we lost? We've made a sketch, we've put a rectangle down, and we've learned how to add the dimensions we want to. The D key only works after you've actually put your sketch down, and to use the dimension, you have to click on one of the lines, highlight it, then hit the D key. So after you've clicked, you hit the D key, and it'll add that dimension to the object.
David?
So you can
also, if you look on your menus, the 5th item on your menu with the 2 arrows is the dimension. It looks just like the dimension. If you click that and then click a line, it'll take you into the dimension mode too. So if you don't know the shortcuts, you can do that. You can also click on the create, and there's a drop down there too.
Yeah, so I mean, there's many. That's the awesome thing about Fusion is like right here is the dimension. So just remember though that you want to be clicked in on your sketch before you hit D or before you go create and do the dimensions. It's the proper way to build a sketch. Greg, I think your mic is on Teams and YouTube or something. So they're hearing echo.
Oops.
Bad Greg.
Sorry.
So anyway, it's good. It's good. So we have our
show them
dimension
the right click on
rectangles.
one of the lines too.
Yeah, sorry, I right clicked on the wrong one. So if you go right click, and then you can go down to sketch dimension as well. So right clicking brings up this sub menu. Honestly, there's lots you can do in there, but there's also a lot in there that gets how we say dangerous. You can do a lot of stuff you don't mean to. If you click a line on a sketch, you can drag that sketch around and you can see it moves as one object. So my rectangle is moving, but I cannot like make this bigger by dragging it. But that's exactly why we have our dimensions in there. So we can't actually change it. So I'm just going to delete this rectangle because I only want one rectangle, and we can actually just select it and delete it. If you're designing something that's relatively complex, right now we have a rectangle, so there's not a lot going on. But remember, you can move these little like reference lines and you up and down. So if they're in the way, you can pull them out of the way and keep sketching. So the next thing we're going to do, I'm just going to we're going to go into our menu here, and we're going to go to the text because we're making a nameplate. So this is one way we can do it, and we can click text. I can type text in here. But for my example, I want to show you one more thing before we add text. So to move around in Fusion, there's on your mouse, and please don't, I mean, I use Fusion on my laptop all the time, but it's going to be a pain in the butt without a mouse. So always have a mouse handy because lots of the rotate stuff goes away. So like when we're talking about moving our sketch around, we can orbit. We can, yeah, it is a pain, totally a pain. If we want to move our sketch back and forth, because when we're in a sketch, so we're doing our sketch right now, we're only in a 2D design plane. So really we only need to move up and down and side to side. To do that, we hold the click wheel down on the mouse, and then it just lets us orbit around. You can also come down to the bottom menu, and there is tools here to pan, orbit, view, look at. But for right now, we're just going to stick with our mouse button if you have it. Otherwise, you got to click the little hand, and then you have to move it around. And then when you're done with the hand, you have to click select again to get back to editing mode. So we have our rectangle. We want our nameplate roughly this size, which is good. How big and tall do we want it? Well, I'm going to go with a centimeter. We're going to make it chunky. So the next thing we want to do is add an extrude to the model. So if I'm just going to finish my sketch here. So we finished our sketch. We can see I'm still using the middle mouse, but we can see we're left with a rectangle. And that's about it. I can click in the middle of the rectangle and it turns blue. And if you come up to this menu, right beside the create sketch button, so it's kind of in order. So the next one we go extrude, and then it'll bring up an extrude menu. So extrude is going to give our model height where we have length and depth right now. So I'm just using the little orbiter at the top, and I'm going to orbit around so you can see. So you can see our flat rectangle has a little arrow going up. And that's from clicking extrude. You can grab the arrow and drag it, and you can see here it makes the object bigger, smaller, taller. We can also go the other way, which is fun, and we will talk about that. But for now, we want 10 millimeters. So I'm going to do it. I can drag to 10, and it snaps in fairly well. You can actually go to this box and type and hit enter. And then once you do, you're left with, oh yeah, a box. So we've got to the box phase of Fusion now. It's not quite a name tag though, because we don't have a name tag on the top. So we're gonna go back in time like 20 minutes. When we started our sketch, we hit new sketch, and then we picked the plane on the bottom, right? So if I hit new sketch, we picked this plane here, and we had our sketch going. The other thing, so we hit new sketch, and I can actually select the top of the model as the plane for the next sketch. There's another way to do this as well. So if you so you hit new sketch, we can click here. That's one way. The next way is actually have it clicked and then hit new sketch, and it automatically picks that as our sketch plane. So we're going to add a name to our tag, and we are going to just add it there, and we're going to put our text in here, name, and we can do all sorts of things. I rotated it by accident, so this one orbits your name around objects. You can also leverage this much in the same way as Fish did with 3D Builder, and even in Tinkercad, it will wrap an object. So if you put it on a plane, we can actually set it so that it wraps around the object. But so we have name, and then like I can click OK once I get the size right. I think I want it a little bigger. So we can come into the side here, and we can actually change like our height units or text style, the font. One of the easiest ways though is just click OK, and then this becomes like a sketch in itself. Where's the text tool? Let me show you. The text tool, if we didn't catch it, it's create down to text. So everything to do with the sketch for the basic text, lines, rectangles, spleens, all of that kind of stuff falls under the create menu. So now that we have our name, I just centered it. If I wanted to scale it, I could, but I'm pretty happy with the size of my name. But if we did want to scale it, yeah, no worries, man, no worries. If we did want to scale it, we can come to modify, and you can scale the sketch. You can also get there, like Greg said, you can right click on it, and then you can actually get to scale as well. But let's go, we're just going to use the modify menu. Let's keep it all up in the menus today, because there's a lot of shortcuts. And then once I select my name, I can scale it on a point. Good, almost. You just got to pick a point, and then be able to scale it. But I think I have a dimension block, don't I? So we're just going to leave it. So now with the name, you can see I can select it. So there's two ways to do a name tag. We can either inset it into the name tag or have it rise above the name tag. So I'm going to hit extrude again. Now when you're inside this menu, you can access extrude very, very quickly. And this works even not in this menu by hitting E. And then it should give you your extrude values, and you get the little arrow back, and you can go inset, and whoa, you can see the line turns red. That means it's going to cut through the model. So I've gone down through the model. If I come up, it's going to offset it. And obviously I'm not going to make a name tag with like a 50 millimeter name sticking out the top. Maybe 2 millimeters is good. So I come to the box on the side here, and I just hit 2 millimeters. No worries. Now this is a cool feature. If you wanted the name to cut all the way through the model, you can actually hit extrude. The little arrow shows up. You can zoom it a bit so it's easier to see. You can turn the model, and then you can actually click the bottom of the model, and then that'll pull it right down to the other side, so the opposite wall. I am just going to really quickly resize my screen because I think we might be a little small. I just got the interrupt here. So while I'm doing that, are there any questions? Have I lost anybody? So we have extrude, which makes our body. We can do another plane on top of the body, so we can construct on top of the body. And then we can also go and we can change the cut direction just by clicking the opposite side of the body. So those are kind of the steps we just took. And this one is going to be, unlike the examples up there, but I think we're going to move on to the next part if we're okay. Thumbs up if we're okay in the chat. Just going to shrink Fusion and open it because I've made it giant sized. There we go. And you might have to resize my video on the YouTubes, Greg. Sorry about that. No questions? We're good? I don't see questions, so I'm going to keep on trucking. All right, so we're going to leave our name tag object. We're going to cut down through. Cole says thumbs up. Awesome. So this is a very basic feature of Fusion. Extrude, cut, draw, right? And you can do some pretty amazing things with just extrude, cut, and draw. So like right now, if we were to print off our name tag, we have like solid corners. We have the name that cut through the whole thing. Why is my text backwards? Is it backwards for everybody or just one person? Oh, what if my text is backwards? Yeah, flip it 180. So you can, we showed that in the video there. You can actually grab the text and rotate it. So when you first make the text, you can see all the little lines here. That means it's been constrained. And I don't know if we'll have enough time to talk about all of those, but we will definitely try to get there. But when you first make a text bubble, I'll just show that quick. There we go. Text. We'll call it Steve because Steve. Let's zoom out a bit and find where I put it. So you see here, Steve is upside down, and then after I hit enter, it made it. So let's go Control Z, and we're going to go create text one more time. Just going to pop that in there. We're going to put Steve back there, and it is upside down backwards, which is fine. Just use this rotatey guy. Pop. And you can rotate it in and you can move it around. So while you're in this text mode, if you grab the white bubble, whoa, you can move it all around and drop it where you want. We did that before, so that should be fine. So I'm just going to finish that sketch. The other cool thing is if you're not sure when something happened in Fusion, so we're not sure at what point we added name to the project, we can actually go down to our timeline and you can start rewinding with these buttons down here. So if you just go on the rewind button, not the one with the solid line, but the one just to the right of the first one, and you click back, it'll take you through all the steps you've done to make your project. So this is a really powerful tool for teaching because not only can you go back and see what you've designed, but let's say a student hands in a project and it looks suspiciously like another student's project, you could go back in the Fusion timeline and see if they didn't just drop in another project in the timeline and discover that, well, maybe they were cheating a little bit, which, you know, it happens, I'm sure. So this name tag's pretty good right now, pretty good, but we can make it better. Now in both Builder and Tinkercad, chamfering is not bad. So a chamfered corner is one that's just, it's a corner or an edge of a piece that's cut on an angle. So a chamfer is just an angle, whereas a fillet is a rounded edge. So chamfers are easier to print if you're printing straight off of the build plate. Fillets are easier to print if you're printing vertically. So I'll show you what I mean here. So let me give you an example. On the top of our name tag here, we're going to add a chamfer. And the chamfer tool and the other tools that we're going to use actually are in the modify menu. So now that we have our body, let's make it look pretty. So I'll click modify and then I'll go down to chamfer. And you can see by the example, it's showing you that a chamfer can cut the corner at an angle. That's what a chamfer does. So let's try a chamfer. You can chamfer down to the height of your object. So if you build a 10 millimeter object, in general, you can go 10 millimeters at a max down, and then it will not work. So you can see it gets to 10, and then if I try to go farther, it goes, whoa, I can't compute that, bad things, But generally speaking, we just want a nice little edge. So that's the first piece. We can add a chamfer if you add a chamfer without picking an edge, so right now I have nothing picked. I can pick an edge by just clicking an edge, but I will have nothing picked. I'm going to go modify and chamfer. And now I can pick my edges. So I could pick the whole top of the model here at once. And you can see I've got 4 blue lines highlighted. And then I can just grab the arrow, drag it down, and you can see it pulled that whole piece down. This whole process, I mean, I talked about it a bit, but that's like a 5-second process, Greg?
Absolutely.
It's something we do all the time, but that process in Tinkercad or even in Builder takes
Hours.
too much time. Yeah, because you got to plan, and that's no fun. So chamfer is the first one. Now, I'm just going to cancel my chamfer. By default in the menu, they give us a fillet as well. Ooh. And you can see the fillet has the rounded edges. So let's just click fillet. And remember, I don't have any of my lines selected, but now I can go into my model, and it's inconvenient behind the menu, so I'll just drag it a bit. Select it. Oh. Ooh. Right? So now we have 4 filleted edges, which is awesome. One pro tip, and I'm sure anybody that's used Fusion before, is don't finish your model with fillets or chamfers until you're done modeling.
Oh,
because once you fillet this, it becomes incredibly difficult to actually modify it. So let me show you kind of what I mean as a general rule. So I'm just going to cancel my fillet for now. We're just going to rotate with our tool up here back, and we have name, move it up a bit, there, centered. So this whole setting here is going to be, we're going to take this model and I'm going to make it a bit bigger. There's 2 ways to do it, quick ways. Your timeline, we know where the rectangle was. So we can come back in our timeline to the rectangle sketch, or we can open the side menu here, and we can see here that we've made 1, 2, 3 bodies, and you can hide them to see what they are. So here's our bodies, and then we'll go up, build, and there they are all back. Right now I can tell you with a fact this probably wouldn't print very well because the E has a hole in it, and that's why we ended up with 3 bodies. So there's 2 things we got to fix. One, we want this to be bigger. We know that our first sketch was our rectangle. If we wanted to, we could actually go here, just single click, and let's call this rectangle. Actually, let's go to rec because I don't want to spell rectangle. And then we know this one is the name. So we just name them quick, no worries there. So if I go in, click on my rectangle and just double click, it should pull me into the sketch, which it does. We're back here. We've already made our sketch dimensions, so it's an easy fix. We can go 80. So we decided now that we wanted this actually 80. Not even, yeah, that's better. And then we actually want this about, whoa, that's my bad. 80, enter, there. Got to hit enter, otherwise weird things happen. And then 40. And then finish. So all we did was double click, then we click our dimensions on the number, it brings up the wizard, you double click, and then you type your new number in. Finish sketch, and now it's actually modified, or you can tell because the name is offset higher on the piece, so it's made the rectangle actually bigger. And if you need proof, you can click the bottom line here, and you can see that it's 80 millimeters now. So hey, easy resizing. The other way to do it on the fly is you can use a push and pull function. So if I wanted the name tag to be 45 millimeters and I didn't want to go edit my sketch, I can click this plane here, and right here is a press and pull. So it's right here, or it's first one in the menu, or you can use Q. 3 different ways for you folks. So press and pull, we'll just click the button up top here. And then you can grab it and pull it out 5 millimeters, and now that's 45. So there's a few different ways to actually modify the size and shape. I always like to go back to the sketch personally, but if you're just doing something quick and dirty and you don't mind having the sketch a different size, it's okay to do it that way. So the other thing I mentioned was, this will not print because the E Do you guys see how this right here is floating? Does everybody see that? Question mark? Did I lose everybody with that statement? Are we following along so well that everybody's just doing it? Give me a thumbs up if we're okay. See it. Awesome. Okay, thanks, Andy. Anyway, if I hide my body, I can tell that there's two. So I just hid my body. 3. You can see the A and the E are a problem area. And that's because in my original extrude, remember how we were practicing cutting through? I just went to the bottom. So an easy fix for this one is I don't need it hollow. So if I come to this extrude, which I know is the one that built my body, but if I wasn't sure, I could just back up in the timeline and go, okay, that's where name showed up. So this is the object I want. I double click that. It'll bring me into the extrude. And instead of -10, let's just, we don't need that big of a space for our name tag. So we could go -2. And then there. So if I unclick it now, you can see that it's pulled the name up and everything's one body. So Fusion was smart enough to just merge all of it now. In the extrude menu, you can choose exactly what you want to do. If you're doing a cut, it assumes that you're cutting from your rectangle and you don't want to keep all the cutting tool parts, so it just cuts it. If you're joining two bodies, so if I were to change this to 2 millimeters, which goes up, you can actually tell it to make a new body out of the second part, and that becomes handy if you wanted to edit it. But we're going to stick with our cut. Yeah, I know. And we're going to click OK. So Fusion always will give you pointers. Like that one was like, I don't have a target body. That's because we had already cut it. So that's cut, push and pull, fillet, chamfers. The other feature that's kind of cool in Fusion that makes it easy to design boxes and such is the hole tool. So I'm going to show you guys really quickly how that works. So I'm just going to right click on my, let's save this. That's a good start. I'm just going to hit Control S to save it. You should save often in Fusion, even though I haven't, because Fusion will crash. And since there's no local copy, if it crashes at the wrong time, you might lose some of your project. Never happened to me. How about you, Greg?
Never.
Never. So save. Yes. Now, I've saved my object. So let's call our name tag done, but we wanted to build a little box that the name tag can fit in. So first we're going to go up, right click, new component. So new component is just when you want to add something to the model, but you don't necessarily want to work with the same bodies and sketches in the same place. So we're going to have to use our memories a little bit. So our name tag was 40 by 80. We did that. If you want to go back and double check that, or even simpler, you can click the line 40 and 80. With this program, to use if I have a model too big for my build plate. No, if you have a model too big for your build plate and you want to cut it, I would use Tinkercad as a cutting process. I mean, I'm going to show you how to do it in here, and it's something you can do, but Tinkercad or even Prusa Slicer, Kira can all do those things without actually having. Yeah, 3D Builder. So the slicer can actually cut a piece for you, Andy. And we're going to show all about slicers and stuff on Tuesday. So, but yes, you can use probably the slicer to scale if it's that, if you don't mind if the dimensions changed, or if it has to be accurate, you can use the slicer to split. So you can actually split it in half, and we will show you all those magic tools next week. This week we're just talking.
I've had large objects that I needed. They didn't give a split up STL, and I needed it in 4 pieces to keep it nice and large. And I just used 3D Builder and sliced it into 3 separate objects. And then I could print each of those objects and then glue them together afterwards. So that's one way of doing it, but Fusion way more advanced. But
Fusion can
quick and dirty.
on Yeah, I mean, I do it in Fusion now, but when I first started, I couldn't be bothered with the processes. So we made a new component. We're on a new component. We want to build a box that goes around this box. So what we're going to do is actually rotate a bit, and then I'm going to start a new sketch. So I'm just going to hit new sketch, and I can actually select the bottom of the other one as the sketch, but or the top. So I'm just going to grab that. We're going to build up, down, which is okay. So I have one more question. Okay. So we have our new sketch. We've built it over our model. The handy part with using this as the sketch plane is we know the dimensions of this rectangle now. So one thing, we're going to start with a couple things, but remember, we're just building a box to fit the 10 millimeter tall rectangle. I'm not going to make it in Fusion so that it actually, you'll see what I mean. So we're just going to go into Fusion. We're going to create a rectangle, and we're going to create a center rectangle. And so Fusion actually has some pretty cool lock functions. So if you wanted to find the center of your model, just go relatively where you think it is, and the X shows up. Then you can go down, and eventually it will lock in the middle. Now this one has that name in the middle, so it's going to be problematic, unfortunately. Let's see if we can hide that. No, that's okay. So we want to find center, and this is going to be a garbled mess in here. So we're just going to zoom in. There's center, and as you go down, you see that blue line that showed up. It's a reference point, so we can see the blue line goes down just a little bit beside the M right here. Can I get it?
Yeah,
I want to get it.
Here it is. You had it.
I know. I should just right there. I did it. So now if we were to bring our center rectangle, we can look at the dimensions, and they are accurate. Like it is, if I get to the edge, see I got 80 by 40. So center rectangle logic here is we want this to fit on the box. We want it to fit over. So I need a lip. You're going to give it 42, not 452, 42. And then, dear, don't move the mouse. Don't do it. 42 and 82, and that'll give me a 2 millimeter gap around. And then I hit enter. So at this point, I can hide my other body. And we're just working with this sketch now. So I'm going to finish my sketch. We want the box to fit over top of the other part. So I'm just going to go in here. Now you can see here, because I used the top of the other box as a sketch plane, this part here is still showing. So I actually have to go in and this is the fun part. You got to click all of this, which is fine. It's not too bad. It's 4 things and one on the outside. So I'm selecting all of this in my sketch, so it's blue, and then I'm just going to select this part, and that should make one solid extrusion. Now we know that we extruded 10 millimeters before, so let's extrude up, and we're going to extrude approximately 10 millimeters. Let's go 10, actually let's go 11, so we have a millimeter gap on the top. Yes. Okay, so now we have our new object. So I did 12 millimeters. You can see here, here's 12. And then there's 82. And then there's 42. I'm sort of lost now, so I need to play with Fusion later. Don't worry, it's all going to make sense in a second. So all we've done, to recap what we have done, is we've made a box that's 2 millimeters bigger in every axis to our name tag. And now we click the box, we click make hollow or shell, and then you can actually change the dimensions of the inside of the box, and you can start your shell where you want to. So since we started our shell at 2 millimeters bigger, we can actually set it at 1 millimeter, and then I click OK, and now one click of the button, I have a box that's going to fit over my name tag. So let's bring our name tag back. You back? Yeah. So you can see here that the name tag is the right size on the outside for the box, and on the inside of the box, we have a 1 millimeter space, so it will fit in if printed. So let's take this one component here. And we're going to do some fusion magic here. Maybe move. So if you hit M, or you can grab it from the, I've never used it from the other menu. It's in modify, M for move. I've always used the hotkey, sorry guys. So I'm just gonna move my box up. So I'm just gonna, and then at the bottom, I'm going to capture. So the capture position moves the component permanently to that spot. If you don't click this box, it's fine. There's just a capture position button up here you're going to have to click. And then you can see in our timeline now, this timeline down here is all for our box on top. So there's all the moves we made. So we had a sketch, we had an extrude, and we had a shell. 3 things. We've only done 3 things, and we've actually made this model very, very workable. So I'm just going to go to the very top of the tree. Whenever the radio button at the top is active, all the models are viewable in the sketch. If you just want to work on component 1, it's important that you toggle the radio button. Otherwise, you'll be working in the other component, and then there was no point in starting a new
Never
component.
done that before.
No, never. Can you pull them apart to be side by side? Heck yeah, I'm going to actually. I just wanted to show you a top view here, so you can see how that box goes over my model. And it's actually kind of nice. So let's pull it apart for Andy here. So let's go through the steps. I'm going to click my component, make it active. I'm going to hit M, or I can go modify and move. So we'll do that. The little arrows come up, and then if I grab the center one, it's kind of like a free moving one. So there's side by side, right there. Boom. Yeah, of course, Andy, just for you. And then I'm going to click capture at the end of that. And then now, Andy, just for Andy. Okay, and for everybody else too. Oh, I didn't move it quite far enough, so I need to edit my move. But you can see now they're side by side. And usually when I start a new component, I might just draw it off to the side and work on dimensions if it's something like this. But I'm going to show you an example of one thing, and then I want to show you one more big feature in Fusion. But so right now we have a name tag. So on a scale of 1 to 10, throw up in the chat, and I am watching the YouTube chat for John there too. On a scale of 1 to 10, 10 being like totally confused, 1 being not confused at all, how are we all doing? Let's take a poll. What's the level of comfort with this
94.
example, sir? Cause somebody throw something at Greg Fisher, I tell you. It's too bad it's digital. So we got a 4, a 5, 5, 6, like Kurt need to play. Absolutely. And Fusion is one thing that it doesn't come like super naturally, especially if you're used to something like Tinkercad or Builder. It's a completely sketch based. 5 need practice. Awesome. You know what? That's it. And that's where I thought we would be. Now, for you guys, I'm going to finish moving this component just because it bothers me, Andy. There we go. I'm throwing Andy under the bus for no reason here. I'm sorry, buddy. I'm going to click the capture position at the bottom this time, so I don't have to click capture position at the top. We are going to export this file right now. Now, remember when I said Fusion files are usually online? They are, but we're done. We want to export this. I want to share it with you guys. So this is not for printing at this moment. I want to share this file with my class or with you guys. So wouldn't working in here be best? To me, it's like working paint versus, yes, you are totally right, Andy. I'm going to click down the little drop. Then I'm going to go export. You have to use the export to get this file. So Fusion 360 files have the F3D. So we're going to call this name tag. And then we're going to export. I just want to make sure I'm exporting to a folder that I know where it is, right? Let's just go big derp. Yep, perfect. Export. So I'm going to throw one more hint out there. because there is homework. Because we split this into 2 days, we want you guys to reproduce the name tag experiment. So if you don't want to start in Builder or Tinkercad, you don't have to. I mean, it would be cool if we would get all three going, but I want the name tag experience is homework. So, Greg, you might have to shrink my screen because I'm about to do something crazy.
Okay.
I'm just fixing what I messed up, so it's really big. So what we're going to get you to do is we're going to get you in, and we're going to get you to use Fusion. Now, this is the reason I exported it. I'm going to go into the OneDrive that we shared with you, and I'm going to make sure the link doesn't expire tonight. But we're going to go into the OneDrive. I'm putting this right in your OneDrive folder for all you wonderful people, and then you can open it at home, and that will actually give you access to it. I'm just going to do it off screen because I have to log in, and to do that I got to go to the email page, and I don't want you all to see email stuff. So sorry, but we're going to do it off screen. You can't see me upload a file, although I hope all of you know how to do this. So we're going and then we'll all judge them harshly when we're together again. John, good question. So John on the YouTube chat asks, how do you orbit like in Tinkercad control? So orbit is actually easily done in Fusion by using this top button in the corner and just dragging it around, and you can orbit around your object, and then use the center mouse button to pan the object back and forth. And that's the easiest way to accomplish this in Fusion. So I'll dump that file in there for you guys, and then the next thing I'm showing you right now is going to be Revolve for a Vase. So our good friend Greg, hi Greg. Our good friend Greg made a vase in Tinkercad, and we're going to reproduce that.
I think you can
right
make
now.
it better.
We can, and I'm going to show. No offense, buddy. I really liked your vase. I'm sorry.
It was modern art.
It was modern art. So right now we have name tag saved in our advanced demo. We need a new file. So we're still in our advanced demo here, but we need a new file. So if I go file, I can go new, and it'll pop up a design beside my design. Wow, look at that. This time I'm going to save it first. We're going to call it Vase. Okay, so that was just file open Vase. I think that's okay for everybody. If you missed the step, let me know. So to do a vase, we're still going to need to make a sketch. But this is where it gets funky and awesome. So I'm going to do that, upload the file after, because it is being a bear right now. I'll wait for my OneDrive to open and then throw it in there for you guys so I can show you how to import it before you're gone. Okay, shoot. We're going to start a new sketch. Now, see this giant window here? It's annoying sometimes because it's giant and in the way. You can hide that by clicking the waffles. So these waffles up here will actually give you full access to your workspace. Yay! So we're still in our make it. We still have our advanced 3D base. We're going to click new sketch. Everything starts with new sketch. This time my sketch plane is going to be one of the vertical axes. It doesn't matter to me. So I'm going to click this one because my mouse is over it. But if you choose a different one, that's totally fine. So you can see here, if I go to the right view, so you can click right on the orbiter or use the little arrows to orbit around like quickly and snap. So this is the right side of my model. Okay. Now, when we're going to make a new sketch, we're making a vase. So let's think about a few things. First, we have to know trigonometry. Not a whole lot. But the bottom of our vase is going to be round, right? So how big do we want the bottom of our vase to be? So I'm going to go with, I want a nice base. So I'm going to make it 6 centimeters. 6 centimeters. So what's that converted to millimeters, everybody? I'm kidding. I'm sorry. Bad joke. So I'm going to grab the line. We haven't used it before, but it's a fun tool. So I'm going to grab the line, and then I'm going to click on the center of the sketch, and then I'm going to bring the line out 30 millimeters. So I have 30 millimeters out. All of this is going to make sense in about 2 seconds. So I have 30 millimeters out. I want my vase to be approximately, so this is really like where you get to decide how tall, how big, right? We don't have an exact number here. So let's say we want a vase that's just big enough for like one little flower. Let's see, a rose or something. So I want my vase. I'm going to bring up a line from the middle again. So click the middle, bring up a line. And again, I'm going to dimension this line. So as soon as I type in a number in that flashing blue area, that dimensions it. So I'm going to type in, let's see here. Let's go 10 centimeters, which is 100 millimeters. Well, that seems kind of short. Let's do 140. Yeah, that seems better. So right now we have two lines. We have one that's 140 millimeters, and we have one that is the 30 millimeters, okay? Now, I'm going to click the line that goes vertical. So see, it's blue now. I'm going to click construction. So what that makes this line, it changes it into a little dotty thing. So the line is there, and Fusion knows that that line is there just for my reference now. It doesn't mean anything, but it's a reference line for me. So if you do extrudes or anything like that, it's not going to chunk your object apart anymore. So sorry, I was reading questions. So we're going to do two more things here. We have our sideways, but now we want to make our vase go from here, our top point, and somehow connect to the bottom point. Now, since we're thinking in Fusion 360, remember, right now we're in a 2D sketch plane. So what we're trying to sketch out is just like almost the silhouette of the vase. Okay, so I'm going to grab my line tool, and I'm going to make my top of the vase slightly smaller than the bottom of the vase. So I click the top of our construction line that adds the line start tool, and I know that my bottom value was 30, so I'm just gonna go 28. Let's go 26. The reason for this is more structural than anything. You don't want a top heavy vase. That's a bad idea. So we go 26 at the top. So now I have two lines floating far away from each other. So there's a couple ways to connect the dots here. So we need to connect this dot, this outside dot right here. I'll right click this one in the middle of all this right clickies. And we're connecting this one in the middle of all the right clickies. Okay. And then what we're going to do is I'm going to actually grab a line tool. And if you hold down on the line tool, so I'm not letting go, do you see how it makes this kind of like curvy featured function now? So if you hold the right click down while you click it, it will make it curve. Okay, so that's one option. So if I were to go to the bottom of my vase, and another pro tip in Fusion, guys, is if you make a line and you're like, oh, I don't want the line there, and I don't want to hit Control Z once it builds the line, just hit escape. It'll pop you out of that wizard real quick. So I'm going to make a vase. I'm going to start at the bottom. I'm holding my click button, and let's just move it about here. Just, you know, I'm just picking what looks good to me right now. So I'll leave it there, and then I'll grab this and drag up until I like it, or I might not like it at all, right? So I'm going to leave it there. And so you see how I have a gradual angle going up towards the top of my vase? Now, these lines are actually based on tangents. So you can see here, there's a gray line that's going from the middle and pointing arrows. So that's the one downside when you use this click and go. You want to make sure that you're tangent connected to the line. So you'll have to make sure that you click and drag the right way. And there's ways to change that, but we will talk about those probably a bit later. And then I just grabbed a point, the last point I got, and I can drag it. See? Whoa, it's all crazy, liney. Don't go too crazy, because then you break your sketch, apparently. Uh-oh. Yay! I'm just going to drag it in a bit, because I want it more plum-shaped. So that's pretty good. So it's not going to be the most pretty vase right now, but it will be a vase. So I'm just going to click Finish Sketch. So this is what we're left with. Now that you can actually see, we have half a vase silhouette. We built half a vase silhouette. So we have this construction line, and I'm actually going to go in and change this to a solid, I think, but we'll decide in a minute. I have a top, I have a bottom, and I have a side. So if you go into the Create menu, there is a Revolve feature. Okay, the Revolve feature doesn't have a hotkey, so sorry, but it's also available right off the top here. It's the first option in Surface, and that is Revolve. So if I click that, I get into the Revolve menu just like I do the others. So it says select a profile, and you can see here, and this is why I have to change my line back. Now that I'm finished constructing, if I click and click and click and click, it will not let me pick, because the construction line I was using as a reference while we were drawing is actually not a solid feature. But we can change it easy. Remember, editing sketches is easy as either opening the sketch and double clicking it here, or from the timeline. So since we only have one, it's really easy to find those. Double click. So I click construction line. So I'm just going to click that dotted line. And you can see here on the side, we have all these menus, which is amazing. And the first one is construction. So if I untick construction, because I ticked it before when we were just starting to get a rough idea, it will convert that line back into a solid. And you can see it's filled it with this nice blue color, which means now that is a profile. So I can extrude profiles. I can't extrude blank spaces. So if I were to click this again, it basically breaks the wall holding back that water, the blue, and it can get out, so it's not a solid piece anymore. So I have to actually click it. Oh, sorry, click it, and then it becomes solid again. And then I can click Finish Sketch. And then I can click my profile, which is just the blue shape right now. I'm looking at it from the right. I'm going to click Revolve. The one thing it asks is which axis do you want to revolve on, and sometimes it's really hard to get the axis you want. But if you have, when we built our sketch, we built it on this axis here, so we actually selected the right sketch plane. So if I actually pick the middle, it will do magic in front of our eyes and create an object for us. This is based off the sketch. Word to the wise, sometimes things go horribly wrong, and what you think you're going to get out of a Revolve looks a bit adult content-ish. So just be careful with your sketches, and if you're doing a live demo, make sure you know what you want to draw before you do it for students. So we have a pot, basically. We can see that if we rotate orbit just up, our pot actually has right here a 30 millimeter circumference, and then it has a 50. So that means that between here and here should be our 60. So the inspect tool is like your ruler. So I click there, I see the little one pop up, which means I selected there before I clicked the one, and then I click here. Oh, I missed. Let's try again. Gotta make sure you hit the circle you're after, otherwise it just disappears. 2. So then it gives you all the information about your circle underneath. So the diameter is 60, which is what we want. That was spot on. We got our 30 millimeters added up to 60. There's our radius, which was the 30. So this couldn't have gone better. So remember, This is why I said trigonometry at the beginning of this pot section. The trigonometry involved isn't hard, but it is something that you'll have to think about while you're building objects like this. So you always want to build half of an object with a revolve, but revolve, aside from the other features we showed you, extrude and push and pull, is one of the big ones that you'll use all the time. Now, unfortunately, before I go on though, questions about revolve? Anybody have any questions? Do you see the method and the madness now that the end result of the vase is up? We sketch a silhouette and we use the revolve tool. So I don't see any questions popping up, so we will mosey.
We might have scared them all away.
So I think couch drinking or something right now. I don't know. It's tough to tell. It's definitely a different learning curve when you start Fusion, but don't give up. So when we click modify this time, I'm going to select the top part. And remember, we used the shell tool to make our box. If I click that again, it gets weird very, very quickly. So you can see here that it did make a shell inside, but it's actually not quite what I want. So it's making a 10 millimeter shell. And oh man, so wonky, very, very wonky. So one way, if you wanted to make a hollow object, because a vase that doesn't have a holes is just no good. To make it hollow, just give it a line thickness. Ah, yes, sir. That's exactly, you've hit the nail on the head, John. So if we go into our sketch again, this is our base sketch. We already used it to revolve. I can actually take this feature and this feature and this feature and this feature and this feature, and I can actually offset it. The offset is the O menu. So if you go up with an offset and then I click I want 1 millimeter. We're gonna go 1 millimeter offset position. Click OK. So now what that's done is it's actually made like a lip. See, look, magic lip. But notice it's not full yet. So there's only 2 changes we have to make. In our model, we want this to be hollow. So I'm going to delete the top 2 lines. Delete, delete. Right here, we know that this line here should be parallel, and it is parallel with our center line. So I'm going to hit line tool, and I'm actually just going to draw straight through it. And then there should be an OK button, but if there's not, just hit, they got rid of the check mark, Greg. They just did an update. So I have my line there. It wanted me to start another line, so I'm just going to hit escape. And you can see here it left my line there. But I still don't have a nice blue solid object, which means it's not sealed down here. So if I come down to my last corner edge and I do a line tool and join that, you can see that now that's a blue edge. I hope I haven't lost. So we did delete, delete. Offset tool, which is O. You can also get offset under the modify menu. Offset. So offset lets you really quickly change a shape, pull it out from the other shape, and it will dimension it larger if you're going bigger or smaller if you're coming inside of the object. So offset tool. And now that we have our lines connected, so always make sure that all your dots are connected. It's a good way to look at it. Click finish. The only one that's not connected right now is the center line, because it actually didn't offset because I didn't tell it to. Because what we can do here is if I just put a line up here per se, I'm going to click construction, and then I'm going to make sure that I've got my 90-degree angle, and we knew that we offset it 1. So now, oh no, I'm thinking crazy, Greg.
Yeah,
I'm getting ahead of myself.
You don't need to do that.
I'm not making a vase at that point. I'm making a weird thing. Sorry, guys. This is what happens in the Fusion rabbit hole. You're like, I need to do that, but I don't. So I click finish, and it actually already adjusted my revolve for me because it had selected a profile before. So if we go into the revolve, you can see here that the actual plane that's selected. So if I close this profile and I zoom in a bit. So the zoom is just scroll up and down on the button, guys. And I click it. It'll pick that. I can click OK. Usually one direction is sufficient. If you do symmetric, it usually works too. For our vase case, we're just going to leave it one-sided and angle. So now, look at that. Look at that. Let's zoom up. Man, look at that vase. So nice. So we have a vase that we've made. I could have made it in probably 2 minutes, but I wanted to explain the process to all you fine people. And we have a vase. And I would like to point out that in my timeline down here, you can see how many steps it took. 1, 2. So let's ask Greg a question. How many steps did it take to do in I know you can do it in 2 minutes one day. How long did it take you to do it in Tinkercad, Greg, to make the vase there?
A few minutes,
Yeah,
but
right?
quite a few steps, though.
Yeah. Turn this upside down. And actually, the product that we got out of Tinkercad wasn't a vase yet either. It was a solid.
It was.
Right? So we're at the end result. We have our vase. Now, we're going to talk about it on Tuesday, but 3D printing slicers have an amazing feature called spiral vase mode or spiralized contour. So you can actually print a solid in defense of the other method as a vase. So that's exactly the steps to make a semi-solid vase. And it will print. Now, Fusion, when you want to send an object, so this is one of the last things, and then I'm just going to show you a few examples. So when you want to send a project and you want to take that project and send it out to, you have to subtract it. Yes, that's right. John says you could copy it and then subtract the model from the model in Tinkercad, and then it will work. So it's kind of like a life hack. So yes, but John, you're absolutely right. So to get this out and 3D printing, we're not going to talk a whole lot about Fusion and slicing for 3D printers. I will say, yes, it can, but right now that it's kind of buggy. So we're not going to talk about it. But what we will talk about is we want to get this model out to an STL. Now, STLs are probably the most popular version of 3D printing utility files, but they're also one of the worst. And the STL files, and Greg mentioned it in the Tinkercad video too, but STL files are built up of triangles. Thousands and thousands and thousands of triangles. So when you actually see your shape in Fusion here, and we have those curves, it's actually building reverse triangles to build all those curves. And sometimes, no matter what you do, you'll get a model and it will have an error in it. Your slicer will warn you too, and we're going to talk about slicer errors next time, but just mentioning it now. So if the error does occur, one of the biggest features of 3D Builder is repair.
Absolutely.
So you can open an STL and it's just like, boom, I'll repair you. Thank you. Right? I mean, how many times? Like, I've used that a lot because Thingiverse, right? So, and I know Greg uses it too. I don't know if Fish has done much that way yet, but so we have our model. We want to save it as an STL. Right click. You can either right click the top of your project if you see what you want to see on this screen. So we'll right click at the top and you can click save as STL. Export is how you save it for another CAD software. So you have to pick save as an STL. From here, you can leave it as binary format. That is fine. You can preview the mesh. I usually don't. It's high workload for the cloud and Fusion to do that.
Because you get to see all the triangles.
Yes, so it's terrible because it takes an extra 10 minutes to slice it or export it. Refinement is an interesting one. The higher you set this, the more triangles and polygon counts will be on your STL, which means it's a bigger file. However, if you do export a file, so I usually leave mine at medium. And then when I bring it into the slicer, if I notice that it has a blocky texture on the outside, I will come back and raise this up to high. So that's kind of the give and take. You want to set it as low as you can to get away with your model, but if the model is just not performing and it looks bad, go to high. So we'll leave it on medium. If you don't click this send to 3D print utility, so if I just, oops, sorry, don't click it and then I clicked it. You just click OK, it'll just pop up a file explorer for you. And then you can be like, okay, yeah, I will definitely just save it. So I'm just going to save it right on Big Derp here, my hard drive, because I can find it. So that's one way. Now, the other way is you can, again, right-click, save as STL. But if you have a favorite slicer installed, so I can drop this down. So it sees Kira by default. It cannot see Prusa Slicer by default. So that's where the custom one comes in, and then you just point it at the slicer. And then if you click OK, it will blink, and then very, very shortly it will slicer. So that is the design-ish process. So you start with a sketch in Fusion. You use Extrude, push-pull. You can use Revolve is another version of Extrude, I would say. It's one that lets you automatically create a body. Now on your surface, there's make hole, which is a really cool function. It can actually generate just a hole at the center of a point you put, and it will also make sure that you can thread it if you want. So you could countersink your hole with machine threads. But when you're modeling in Fusion, one of the best ways to actually do a hole to like put a screw into is if you know that you have a M3 screw, so like one that's on your 3D printer, one of those machine head screws, and it's an M3. Roughly the size of the screw thread is roughly 2.6 millimeters, I think. So what I would do is I would actually undersize it a bit in Fusion. So I would make a hole in my object, and let me just pop in here. So I'll go to my name tag example, and I'll click my name tag. I'll make a hole. I clicked it. So you can, Clicky McClickerson strikes again. Click once. Select your face. And now you can see it just puts the whole model in there. And so then, like, here's your countersinking type. So if you wanted to thread the hole, it will put threads on that hole. And then you can actually modify everything down here. So my hole here is, looks like it's going to be 30 millimeters. No, it's an M3 screw. Let's make it 2.6. And then let's see here, the width of my screw, 2.6. So it should start, yeah, there we go. And then my countersink, we could make that 3. That would be okay too. Looky, you know what? Rewatching it's going to help a lot. But I just hit cancel because I want to go into Prusa and just show you our vase here. And you know, guys, too, I will put it out there that Greg and I are working on a bit of a Fusion walkthrough, but there are a lot of good guides out there already too. So we've actually added those into the link document for you. So you guys can pick those up from the link document in the shared folder. I've also got the name tag up there so that when you guys are doing Operation Make a Name Tag, I would love for you to make, you can use my example if you want and follow along with the video again to make the name tag. And then you can add some flair to it. So you can cut some holes or put a chamfer or fill it, do all sorts of neat things. I'm going to add a new folder inside of your class folder that we shared out with you. And I'm going to just call it name tags. And once you finish, if you do, it's by no means are you obligated to finish it. To see it, plop it in there, and Sunday afternoon, night, I will take a look at that, and we will get to printing. So you can see that my model in Prusa Slicer here, our little vase, coming back to the vase, looks pretty okay actually, doesn't it? You can see here that there is some blockiness on the model. Now, before we panic about that, we'll probably slice it. So I'll hit slice. And it'll just take it through. I haven't changed any settings, and we're talking about the slicer portion on Tuesday. I just want to show you how it looks after it's completed. So we'll let that chug away for a second. I just want to show you some examples really quick, and Greg might want to jump in too on a few of them, but I'm just going to show you an example here of kind of what we've done with Fusion and where you can take it. And by no means are I mean, I've been using Fusion for like 2 years now, but we're not. I
still
think
don't know
anybody
all
really
the
could be.
features. There's so many.
There's so many. I bet you even the guys at Autodesk are like, I need to get the manual out. So there's lots of cool things and simple things we can make. But one thing that Greg and I kind of collabed on over a summer here, I think it might be actually in work, isn't it, Greg? I think I put it in the work project. Yeah, pop out of here. There it is. I think, yeah, here we go. Here's the work things. Is a bracket. Now, anybody that's had like projectors installed in schools and stuff, this is kind of this is Fusion functional modeling at its best. So I think I double clicked it, so I'm just going to give it a second. Okay, I didn't. Okay, so it'll always say open document down here, and my head's in the way, but you'll see the line start working and it'll pull it in. So while that's pulling in, oh yeah, you can see the vase actually turns out really good. There's not too much polygoning going on. Vase, it would work. It would. I don't know if it'd be watertight. That's another problem with 3D printing is all the testing that goes into watertight. So here it is. All of this was done with cut, extrude, offset sketches. So that's where we click the model and then pick new sketch. And this is just it's an end result. It's something that we can eventually we work towards. And the design of this, the adapters clip into this, and then we screw these into the wall above the roof, and they hold all the cables for the projectors that go back and forth in the classrooms. And I think we calculated it out. What was it, about 32 cents or something like that to print one?
Yeah, something like that. And this went through multiple iterations too. Like if you go back in the timeline, it changed quite a bit.
So you could see here too, like Greg mentions in the timeline, just look at all these steps.
There was 18 saves.
So here's, well, if you hit play, it's kind of fun. You can watch the iterations. Yeah, okay, we'll put this here, we'll put this here. This needs to move. And it's a really cool way of actually presenting like a design in the end to your class, because they can see, exactly what it went through. And like lots, like if you see the part that's building now, it's extrude, 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 cut, new sketch, right? So literally your model is almost like a piece of clay. You're taking pieces away so that you can actually manufacture it. And it's one of the last renditions we did was a problem with how it was 3D printing, and we changed the rigidity of some parts on the side. So when you're designing in Fusion, remember your 3D printer can print at a 45-degree angle very, very easily. So just remember that if you're building an angle, so let me show you an example here. See on our posts, it comes up and out. Your 3D printer will be able to print this without support. And actually, you can print this whole object without support. That was one of the fun challenges we had. And you can see, like, we took wings off the thing, so now it's a nice rectangle with some fillets on the corner. And yeah, it's a great project. And this saved, in this case, this saved probably $12. I forget how much they said the other one was, but
I think it was $26.
Yeah, so it was $26.
And then there's the should be able to. There's the end result. That
those on batch in our print farm at the network operating center there, and I forget, I think we do about four sheets,
four
but
per
yeah.
printer. Yeah.
And one thing we do in our designs is we have we have our sketches, so like this piece here, and we stamp it. That's just an extrude, just like we were doing with the name tag. It takes some time. The other cool thing, and I'll pop it up, but this is the other one that I wanted to show off. So and it's actually this one is a Greg GT design. And it's
Sure.
If you want to talk about it, Greg.
Well, we've had a few people that have broken their padcaster here. I'll just flip back to my camera for a second. So here's the aluminum part, and it's for the padcaster, and you can see it got broken. And so I was asked to see if I could 3D print a part. And so I went into Fusion, and it took a while, and a lot of iterations. I think this one has 10 saves on it, but there's a lot of work that went into it to get it to the point where I could print it. And I printed a part, and if it breaks, I can just print another one. It's not quite as strong, but we fixed a couple of people's padcasters. Tripods with this. So.
Yeah, and I mean, if it's not as strong, no big deal. Like literally, your guys' enders that you built last session or the one before, and I don't know if we had John building an ender with us, but as a smaller 3D printer can print these, and so literally you're spending like at most 60 cents on PLA, I think, probably for the whole part.
Yeah.
Right. And we've had stuff like I won't open them, but I've made buckles for the snowshoes the division office checks out. One of my favorite ones that we were asked to do is this one.
Oh, the toilet paper key.
In Fusion. Yeah, so like the janitors all use this toilet paper key, but it kept breaking, the one that they had. So we came up with this quick design that opens the toilet paper locks, and I think last time I printed them about 50 of them because they're not perfect. They don't last forever. But, that's one other really cool design that we were able to bring them. And you could do all of these that I've showed you in Tinkercad, but you are going to be taking time. And I want to come back to Joe. Is extrude, and there's no such thing as cut. It's all object bodies that can cut into each other. So that's one thing that really rings home. So I'm glad that John brought that up. I'm just gonna see if I can't fix my little camera here. Let's flip it over. Yeah, there we go. So that concludes the demo portion. We made it. And I know we jumped through 3D Builder and Tinkercad fast, but we wanted to give Fusion a good amount of time because of the complexity. So, but hey, does anybody in the room have any questions? So I'm watching John, I'm watching Teams, and we've got two other guys watching Teams and YouTube too. So are there any other questions? Is there anything I can answer for you before we let you go? And remember, in our class folder, so many questions, so little time. Well, Fish, you can ask whenever, you know that. So when we look at our class folder, there is the example for the name tag in Fusion now. And to do that, all you have to literally do is go File, Open. And since it's a Fusion design, you just open it up and it will import, and you can save it in your Fusion and continue on. So if you guys want to take part in the Great Name Tag Challenge, I'd like to see a few Fusion ones out there if you can manage it. But hey, if you want a Tinkercad
or 3D Builder,
or 3D Builder, do it. Oh, that's a good question, Greg. Where do we recommend buying Filament? And The answer is
right now.
good luck. Yeah. Um, I buy lots of my filament from Amazon. But when we're buying filament at the school, we always recommend buying from Spool 3D or filaments.ca.
So David and I are authorized to purchase for the schools. So you have to send a blue rec to Johnny, and then we will order. And typically we're going to order from Spool 3D because that's kind of who we standardized on. But right now, with our little situation, and a lot of the filament is actually made in China. Some of it's made in the US, some of it's made in Canada, but the bulk of it is not in Canada. So shipping is the problem. And a lot of people are staying home and they're ordering filament. So there's a lot not available right now. So if I am going to try to check when some shipments might be coming in, but I think they're probably a month or two away, maybe less. You can still buy from Amazon, but they're not shipping priority. And if you do buy from Amazon, and this is for personal stuff because we're not supposed to buy from the district, the prices are super high. So instead of $25 for a spool, it's $50 for a spool. So the prices have almost doubled. So just keep that in mind right now. You might be limited to a few weird colors like skin tone or or something.
Yeah, for sure. And brands like premium brands like Proto Pasta and those ones are available still. Proto Pasta is still cranking out filament, but it's not $20 to $30 a spool. It's $60 a spool. So I mean, Filamentum is actually I have 3 rolls of Filamentum here. It's great. My wife Stacy loves that stuff. It's all shimmery and sparkly, and you never print with it because you're scared of wasting it all. So, but I mean, we're gonna see you guys on Tuesday next week, same bat time. We're at 1:00, right? Yeah. And I want to express my appreciation and thanks for coming along and hanging out digitally with us. It's been a blast.
And so next week we can have a quick question and answer because I'm sure you guys are going to come up with some questions that you run into once you start playing with Fusion or Tinkercad or whichever one you're doing, and bring those to the next one. And don't feel you have to wait. If you want, fire us an email, send us a chat.
Well, and
we will
the Teams is
answer
open.
it.
We're not shutting that. Yeah.
Yeah. So
sure.
So we'll definitely answer it. So don't be shy. I think was your audio off, David?
Hello?
I don't think they were hearing you for some reason. But it's
What?
I don't know. It looks muted, but
It's on now.
Yeah, but either way, next week we will definitely take those questions, and then it's slicing and supports and whatnot. So that's the can be tricky if you're new to this, but once you get the hang of it, you'll be printing amazing things after that.
Yep. So that's where we're heading. So you guys, thanks Greg for everything today, and we're awful happy you guys are here. Take it easy. Have a good one. We're going to shut the live stream off now. But if you have questions, we're on Teams for the next little bit still. So thanks for coming.